In this video, we're going to continue solving systems of equations by substitution. Before this, we did systems of equations by graphing, but sometimes technology is not available and algebraic is actually quicker. So systems of equations, just to review, are two or more equations. So since we are dealing with linear, exponential, and quadratic, you may have one like this, where it's exponential, and then you may even have a quadratic. So the exponential would look like that, and then your quadratic could look like that. And in this case, remember the solutions to your systems of the equations is the intersection points, or points. So in this case, we actually have two solutions. So whatever those points are our solutions. Now keep in mind we could have 0 solutions, we could have 1, 2, sometimes even 3, or many solutions, or infinite solutions when they are the same. So remember, we have learned about 3 functions this year. We have learned about linear, where it just has a single x, like y equals 5x minus 2, where it is a line, or we could have a line going in the opposite direction, or it could be horizontal or vertical. Exponential, when you have x as the exponent, so 4 to the x power, which it can go up, or it can go down. Quadratic, where we have an x squared as our highest exponent. So we could have like 7x squared. So we have parabolas that open up and parabolas that open down. In today's video, algebraically, we are not going to look at exponential. That is a deeper topic on how to solve that way. So we are only going to look at systems that are linear, quadratic, or both linear or both quadratic. To remember, there's types of solutions to our systems. We can have one solution where the two functions only intersect once. So I have 2 linears, or I may have 2 parabolas only intersect once. Could have no solution. Could have a situation like this where you have 2 parabolas that never intersect. We could have a situation we have a linear and parabola. We can have 2 solutions. For example, I can have exponential and maybe a parabola. So we have 2 solutions. Or I may have 2 parabolas, like so. Or I may have many solutions, which if I have a line, I may have a line that's exactly the same. Or maybe I have an exponential curve. And then the exponential curve is exactly the same. Alright, so how to solve a system by substitution. When we did this with just linear, way back in Unit 2, you learned how to do this by substitution. And what I want you to think about with substitution is just replacing. When you substitute in for somebody. Alright. So we are going to replace one of the variables. And when we're done, we're going to sketch the solution, but we'll get to that when you get to that point. So notice here we have y equals. I'm going to take what y equals, right, and replace the y in the other equation. So instead of y here, I'm going to have x squared minus 7x plus 5. Then everything else stays exactly the same, equals x squared minus 4x plus 11. Now in this case, it is still quadratic, and the reason I know it's still quadratic because we have x squareds. So I need it to equal 0 to solve. So I'm going to move everything over to one side. Change colors so you can easily follow along. So I'm just going to minus x squared to both sides. And at the same time, I'm going to add 7x so I can move it to the other side. And then I'm going to subtract 5. Alright. Well, here, everything simplifies out, so I get 0. Over here, my x squares cancel out, or make 0, but I do have 3x plus 6. Now that I just have a single x, I can use old methods that I've been learned for years of how to solve this. So I can minus 6 over negative 6x equals 3x. Divide by 3. X equals 2. Well, that is only half the problem. I have an x and a y, and I need to know what x and y equal. So I now need to solve for y. So to do that is I replace x in one of the two equations. I'm just going to use the top one. But if I use the bottom one, I should get the exact same solution. So y equals 2 squared. Notice I just replaced x minus 7x. Oh, sorry, should not be 7. There we go. Instead of x, it's now 2 plus 5. Again, I'm doing this so I can figure out what my y is. Plugging it in, I get 4 minus 14 plus 5. 4 minus 14 is negative 10, plus 5 is negative 5. So my solution, where these two are going to intersect, is 2, negative 5. Alright, so I need to sketch a graph of my solution. So to do that, notice I have a quadratic and quadratic, so I have two parabolas, x squared and x squared. That's how I know. So I know they need to intersect at 2, negative 5. So let me switch colors. So 2, negative 5 is about right here. Okay. So then, in both my parabolas, I notice they open up. So I'm just going to draw one parabola that intersects here, and then I'm going to draw another parabola that intersects, but it's not going to intersect the other parabola again. Again, there's just a sketch, so I don't want anything super accurate. And again, my solution is 2, negative 5. Alright, so on this one, notice I just have a single x, so I know both of these are lines. These are linear. So I have y equals 4x plus 2. So I'm going to replace the y in the other equation. So I have 3x minus, and now instead of the y, I'm going to put what y equals, 4x plus 2. And everything else stays the same. Here I'm going to distribute the negative. So I get 3x minus 4x minus 2 equals negative 2. That gives me negative x minus 2 equals negative 2. Add 2. Negative x equals 0. Remember, there's a negative 1 in front, so we're going to divide because of multiplication there. So x equals 0. So I only have one variable, but I have two variables here, so I'm going to solve. I'm going to plug into this one because I already have y by itself. So y equals 4. Instead of x, I'm going to put what x equals, which is 0, plus 2. That's 0 plus 2. So y equals 2. So my two lines intersect at 0, 2. So that is my solution, and then I'm just going to sketch a graph. Again, these are two lines, so I'm just going to kind of estimate where 0, 2 is at. Draw one line, maybe I'll draw another line. As long as they're both lines and they intersect about where 0, 2 is at, remember this is 0, 2, I will be okay with it. So now here we have a quadratic, we have a parabola, and we have a line. So again, I have y equals, so I'm going to replace the y in the other equation. So I have x squared minus 4x minus 5 equals negative 6x plus 3. So in this situation, I'm going to move everything over to one side because I still have an x squared to make it equal 0, and I'm going to move it to the left. So So I'm going to do the opposite. So I'm going to add 6x, which I added to the negative 4 because they are like terms, minus 3. These simplify out to give me 0. So I get x squared plus 2x minus 8. Now I still have an x squared, so I have to use one of my ways to solve the quadratic, which is the quadratic formula, completing the square, graphing. We can't use the square root method, or we can factor. I'm going to factor because this one factors, and that is the quickest way, and most of them do factor. So x times x factors a negative 8 that add up to 2 is positive 4 and negative 2. X equals negative 4 and 2. Remember, we do the opposite. So notice I have two solutions, which means there are 2 points of intersection. So from here, I need to plug in twice. I'm going to plug into the linear one because it's a lot simpler. So first I'm going to do negative 4. So y equals negative 6 times negative 4 plus 3. Negative 6 times negative 4 is 24 plus 3, which is 27. So one point of intersection is negative 4, 27. Then I'm going to plug in negative 2, or 2, sorry. Y equals negative 6 times 2 plus 3. Right, so that's negative 12 plus 3. Y equals negative 9. So my point of intersection is 2, negative 9. So I'm going to sketch where they may be. 2, negative 9 is probably going to be down here. Negative 4, 27 is going way up here. So I have a parabola. Okay. And then I also have a line. Again, it's just a sketch. But keep in mind we have 2 solutions because we got 2 answers here. So to review, resistance equations are 2 more equations where solutions have points of intersection, and we may have more than one solution. And the key is if you have x squared, think you need to have it equal 0 and then factor. That's going to be the tricky part. And then you may have 2 solutions. Reminder to do a reflection so you get your extra credit.